Λοιπόν, καλημέρα σε όλους. Good morning and welcome to our online lecture titled Exploring Mining's Future, Unearthing Riches in Digital Innovation. Today we welcome Mr. Eduardo Coloma, CEO of Maptek, who will give us a talk on the transformation of mining through digital technologies. The talk also examines the critical role of emerging technologies like spatial computing and AI in augmenting human expertise, emphasizing that the future belongs to those who can harness technology thoughtfully. A few words first about our speaker. Eduardo began working for Maptek 25 years ago in sales and technical support services in South America. He then moved to Perth, Western Australia in 2012 as sales manager for the Western Australian region, mine planning business manager, and evolution global product manager. Eduardo has knowledge and experience in optimization, mine design, and scheduling, especially for open pit metalliferous deposits. He holds a civil, industrial, and mining engineering degree from the University of Antofagasta, Chile, and completed an executive MBA at Adolfo Ibáñez University in 2008. So, Eduardo, welcome to our university. We're looking forward to your talk.
Thank you very much, Yannis. For me, it's a pleasure to meet you again after a long time. And welcome to all the students that are connected through the for this talk today. Now, I must admit that I don't know how this is going to go because normally, first of all, this is quite long. You know, we're talking about probably an hour and a half presentation. And normally I do this one face-to-face, which I really like the interaction with the crowd there. So it's going to be my first attempt to do it online. So I hope that you can participate and see how this goes. All right. So thank you for having me here. All right, so let's start with the presentation. And I guess one of the aspects, and just to make sure that people can participate here, I'm going to start introducing, a few things. First of all, I want to bring the attention to the crowd out there around when do you think that the wheel was invented in the world? And I really want interaction here. So I don't know how we're going to do it. Maybe put it in the chat, or if someone want to say it, just go for it. And I'm going to wait probably a few seconds. If nothing happens, I'm just going to jump ahead. But ideally, if anyone out there can put when this was invented, that would be great. No? Right. Oh, there you go. We got one comment. 2,000 years ago. All right, a little bit more than that. Anyone else? Yeah, actually it was 3,500 BC. It was invented, the wheel, which obviously is a long time ago. We can run the next thing, and we can say, when do you think the luggage was invented? And again, I need, from you guys, what do you think? This is not about right or wrong. It's just about participation. So please give it a go. 2000 BC. All right. Yeah, close by, 1500 BC. So it's still a lot of time between those two inventions, And I guess probably you know where I'm going. Is anyone know when the luggage with wheels was invented? 1950, yeah, very close to that. Thank you. I'm going to take it for now, which was around the 1970. And I guess, as you can see, a lot of time between the different things that were in there. And I guess the main takeaway that I wanna do from here is that innovation is not always about creating something entirely new, but rather about seeing the every day from a new perspective and, challenging the status quo. The story about this thing that I am putting here is illustrate how a simple idea can actually change things, can change a whole industry around it. But also is also important about how the social convention and resistance to change can actually delay the adoption of it. And I'm gonna take this to start to introduce what I'm going to be talking about. But, if we really look the history of the innovation cycles, we can start probably with the first stage of the Industrial Revolution, which basically was about using water to make stuff like paper, cloth, and iron. Obviously, factories popped up and cities grew around then. And that took probably around 60 years. We're talking about 1785. Then the second wave, or the second stage came in, which is from 1845 to 1900, was all about trains or steam and metal, which accelerated transportation and obviously continued with the urban growth. Then we went to the third wave, or the third stage, in the early 1900s, which actually brought the electricity to us. And with that, the chemicals and the internal combustion engine, which enabled the mass production. Cars became a big deal, especially with the Henry Ford Model T, and the new way of making them with an assembly line. Now we move to the fourth wave, which is basically marked by petrochemicals and electronics. Aviation was an important thing here too, which essentially globalizing manufacturing, but also allow us to travel around the world. And the fifth wave or stage was around the 1990, which is not that far ago, which is what we call the digital era. And that's where it started. Basically, the internet changed how we get information and how we communicate between each other. In other words, it connected the world in different ways. And now we are sitting in the sixth wave, which is, all around smart machine, robots, and drones that are changing our world. Things are getting done faster, and technology is playing a huge role in our life. Now, alongside all this technology growth, there is a big push for clean energy as well in this way. Okay, and we need to tackle the climate change things like solar and wind power and becoming more important and affordable. But 2020 was an important year for everyone. The COVID-19 pandemic wasn't just about a health crisis. It acted as a massive global stress test that accelerate technology adoption by years within months. And it's quite interesting to think about from that perspective, because actually it's an example of paradigm shift in how we work, how we learn, how we buy and sell, how we manage health, and how we interact between each other. So actually, COVID-19 didn't create the digital future. It's just accelerated and moved down faster than we thought initially. Obviously, with this crisis, demonstrate that technology adoption can be driven by necessity, not just by curiosity or sometimes by profit. And the barrier to innovation, let's call it cultural, organizational, psychological, can dissolve quickly when survival is at stake. So now we are entering into the sixth wave, as I was mentioned before, with more urgency, more experimentation, and less tolerance for inefficiency. And as we move from the fifth to the sixth wave of innovation, as I mentioned before, COVID forced the world to rethink speed, scalability, and resilience. Cloud computing, for example, already growing steady, became the backbone of the digital life. It powered everything from remote work to vaccine research, e-commerce, to education. The pandemic didn't just test our health systems, it tests our digital foundation, and cloud stepped up. So by the way, it's important to mention that Maptek is being embracing and using the cloud technology since 2014. So it's nothing new for us, but we need to admit that after the COVID was a first priority for a lot of companies and a lot of people. if we reflect on that one, actually Satya Nadella, which is the CEO of Microsoft, captured this one perfectly. You know, in the early months of the pandemic, digital transformation didn't crawl forward. It actually ran really fast. And at the heart of this transformation was the cloud, which allowed us to respond at that scale. But this quick change showed that everyone started to understand that working from home was feasible. In fact, is feasible, you know. And because of changes, companies basically took down all computer systems, improved the remote access, and moved faster to use more cloud. What happened? We didn't just change how we work. Actually, we totally changed how computers are used. In fact, today, you don't have a clear cloud plan. It's like you don't have a plan at all. And actually, the same applies for mobile devices. You know, mobile devices have become the predominant computing tools worldwide. In fact, another question here for the crowd there, do you know how many smartphones at the moment are worldwide? Any idea? Pick a number and put it out there. Anyone? Yep, we got 7.2 billion smartphones today, as of end of 2024. So it's huge. And another question for you guys, how big is the worldwide population? Any idea? 8.5 billion. Yeah, close enough. 8.2 I got. So we are in that ballpark. But can you see that today we are nearing to a point where there is almost one smartphone for every person on Earth? That's unprecedented. No other technology in human history, not the cars, not the TV, or even the electricity, has expressed this widely, this quickly. So let me look here. Oh, there you go. So smartphones are no longer just tools, actually. They are extension of ourselves. They store our memories, enable our work, guide our movement, and connect us instantly with other people and information anyway. It's actually our primary communication tool. And this moment marks a massive pivot point. When technology becomes this embedded in daily life, the possibilities are endless, from how we learn to how we innovate, govern, and solve global challenges. However, if you ever doubted that your phone is an extension of yourself, try losing it just for one day. We'll see what happens. So anyway, any discussion about the future of computing and our evolving world landscape must consider this device without a doubt and their trajectory as well. And as you can imagine, with around 7.2 billion smartphones worldwide, we have essentially turned every person into a data generator. We like it or not. You know, every tap, swipe, voice message, and picture contributed to the global stream of behavioral and contextual data. This data is a raw material of machine learning. The more data we produce and the more diverse it is, the more patterns machine can find, and the better they get at learning, predicting, and assisting. In other words, our collective behavior is training the algorithms that will shape the future. But if we step back a little bit, you know, even though we have built our incredible digital world, powered by, I don't know, more compute, more cloud, more devices, more data, an ocean of data. But a lot of this is still rests on something very physical and very small, which is the transistor. You know, for decades, we rely on our ability to make transistors smaller, cheaper, and faster, again and again. So I guess anything that I'm saying so far is that nothing really new here. So what we really need to be thinking about, where are going to be the constraints, or what are going to be the biggest roadblocks to continue innovating but it's not related to physics itself. And I want to bring the attention to the Moore law. Basically, this is a guy that was working for IBM. Actually, he's one of the co-founders of IBM. And it was when they were doing the RAM, actually, they started to use this law. By the way, it's not a law in some scientific sense, because we really need to work really hard in order to make it happen. But he basically stated that every 18 to 24 months, for approximately the same cost, we could double the number of circuits on a silicon chip. And in fact, it was predicted, and it's been true 50 years after that. The prediction continued to be true, powering the exponential rise in computing power that made the smartphone, cloud, and AI possible. But it is important to understand that now we are approaching to the limit of the physics. Transistors are approaching the size of atoms, really. They are shrinking a lot and becoming increasingly expensive, technically difficult, and inefficient. So the question is, can we keep double? I think there is no doubt that we can adapt this. So what we really need to be thinking about, what's going to happen when Moore's law started to slow down. And I guess, that's what we really need to be thinking as a big roadblock in the next decade, because essentially it's going to put some question on how we can re-architecture these things. Just to put this one in context, this law, I have taken this picture from Wikipedia. And as you can see, all the evolution of the transistor density in processor, starting from the original Intel 4004 in 1970 to the 2020. And as you can see, it's a perfect line, straight line, a 45 approach slope. Is anyone noting why we got that behavior there? Why it's so straight? Any idea? Because at the first glance, this graph might seem unremarkable, just a straight line going up. But here is the trick. It's basically in an algorithm scale, as you can see here, the y-axis. That means that every step up, the y-axis represents 10x, 100x increase in the transistor count. And as you can see, it's an enormous number. When we start here in 1,000, and now we're talking in the 50 billion by 2020. In fact, I believe that by 2023, AMD, the transistor or the chip that they put it out there is 146 billion transistor count. So it's a massive thing. And basically, what appears a linear thing is actually an exponential growth. The kind that transforms the world, really, And what makes this line even more remarkable is that it has been driven by the human will, not by the natural law. For decades, the chip maker has basically pushed to keep this line going, doubling performance, halving the cost, and unlocking the entire industry in the process. And the reality is, if you look at the data without the logarithmic scale, you're going to see this, what we call the hockey stick graph, as you can see here. But it's quite useless when you analyze long period of time or short period of time with a massive increase, because you got, like a flat, and then jumping. So it doesn't really help us to understand what happened. So let me give you an example of the Moore law in practice. Is anyone familiar what the picture is showing at the moment? And I really need some people here saying something. What do you guys think is the picture? Come on, guys. Okay. Hold on. All right, it's a supercomputer. A Cray, that's right. Yes, that's right. It's basically the Cray XMP. Actually, this is the first supercomputer which was built around 1985. You know, believe it or not, basically cost $50 million and an additional $1 million for storage. Okay. What's interesting on this computer is that they consume 200 kilowatt of power. Okay, so basically you need a dedicated generator, and in order to manage the heat, they were cooled using mineral oil. Without, they simply melted. You know, what is more remarkable is that the computer powered by this thing, and as you can see, you can use it as a furniture as well. But the computer power was 1.9 gigaflop per second, which is probably around 2 billion floating point operation. Which is for those days was massive. You know, people was actually using this one to model nuclear explosion or trying to compute the orbital calculation for the Voyager missions or something like that. You know, very high-end calculations. Now, if we move forward, now we are sitting around 2011. The iPad 2 went to the market, and it cost probably by then $800. And it was, you know, built in with battery, and I think probably 10 hours battery, so there it's highlighted. But guess what? The computer power of this consumer device is actually around 1.9 gigaflop of processing power. So in a span of 29 years or 26 years, we went from this thing to a computer device that actually people can use it. And believe it or not, a lot of people playing just game with it. So it shows how much we have improved as a society. And funnily enough, the speed of this improvement is really mind-blowing. But if you keep pushing, you know, and you jump to probably 2020, you can buy these things. You know, if you are looking for a high performance computing device, you probably are going to invest in a high-end video card, you know, and this is an example of the GeoForce RTX 1490. If you can find one of these, they were very popular with the Bitcoin situation. A lot of people was mining with this. But what I'm going to focus on is on the cost. You know, this is a remarkable unit. You know, has an impressive 16,000 cores and can actually achieve probably around 82 teraflops when operating at full capacity. Now, if we compare this one with the iPad, you know, it's 40,000, so 40 times 1,000, you know, times faster than the iPad 2. And the remarkable thing is that this just happened in 11 years. And then, you know, if you continue pushing the technology, today, when we look at the fastest supercomputer globally, we witness an intense race between the Chinese, the American, the Japanese, you know. This one actually was the previous supercomputer, but the new one is the next one, which is the Capitan. And this was in November 2024, actually raised to the top. And this supercomputer has the capacity of 1.7 exaflop. Again, if we compare, it's 21,000 times the graphical unit that we just saw. And all this progression is not random. It's actually the practical expression of Moore's law. And it showed the exponential scaling in a real world example. But as I mentioned before, for decades, Moore's law was more than an observation. It was a promise. You know, the computer power could keep doubling, fueling innovation after innovation. But now we face the end of life of this law, you know, not because we lack of ambition, but because we are colliding with the law of physics. you know, the complexity of the manufacturing and the cost of continuing with this race. So the slope that we were seeing before in 45 is actually flattening at the moment. Now, the exponential gains we once took for granted are now slower. It's harder and it's more expensive to achieve. You know, so the traditional roadmap for the chip maker is not possible anymore. And why is that? It's because we are reaching unprecedented levels of miniaturization. You know, if you think about it now, when we talk about transistor, we are talking about nanometers. Nanometers. I mean, when you think about measure, you know, you can think about a meters and you got a, you know, an idea of what a meter is, you know, and you can go to the centimeter and you can actually see it. Probably you can feel it in millimeters, but nanometer is very difficult to understand the order of magnitude that we're talking about. In fact, a nanometer is 1 billion of a meter, which is almost incomprehensible scale. Okay, and let me put you in context because again, I don't think that we realize that one. But to illustrate this, consider the following: if you were to wait a million seconds, you will be waiting probably around 11 days. But if you want to wait a billion seconds, that's 32 years. That's the kind of precision and skill that we are working with today. And it's truly remarkable. But, you know, we are already at the scale of 3 nanometers, which is ridiculously small. But there is another aspect of it, you know, is that at the peak of Moore's Law, there was more than 20 companies, you know, producing chips, pushing the boundaries of size, speed, and power, as you can see in this graph. At that point, we were in the range of 130 nanometers, you know. But by 2022, we had only 3 companies remaining, capable of manufacturing chips at the most advanced nodes, you know, the TSMC, Samsung, and Intel. You know, why? Well, because the cost, the complexity, and the risk of staying of the bleeding edge become very, very hard. In other words, the innovation engine that once democratized the progress is now concentrated in the hands of a few, achieved with massive technological and geopolitical implication, but we're not going to go in that angle for now. And I guess what is important here, as the Moore's Law is slow, we are seeing another shift, not in ambition now, but in strategy. You know, what we got in front of us is the DGX GH200, which is the NVIDIA purpose-built AI supercomputer. So rather than simply squeezing more transistors into a chip, this system re-architects the entire computer environment to meet the demands of the AI era. And I think this is mark a fundamental pivot from it, you know, from general purpose computing to purpose optimized AI infrastructure. It's a response not just to the end of the Moore's Law, obviously, but to the rise of the AI as the dominant driver of computing innovation these days. Now, this one in particular is especially designed for AI models. It actually achieved 1 exaflops, which is, again, massive. And NVIDIA claimed that this supercomputer can actually produce AI modeling in weeks and significant acceleration from the previous timeline, which was months. Now, with that said, let's shift our focus away from computer power. I think we talk a lot about computer power, but I just want to make sure, you know, anything that we are thinking moving forward, we really need to understand our constraint. And Moore's Law definitely is one of those. What other constraint do you think that we're going to face moving forward? Well, it is tempting to think that the biggest constraint in AI today is the computer power, but in many cases, it's the network. You know, a few years back, 5G was all the rage and it was heavily advertised, and now it's here, but the transition has been It's very simple, and I could argue that no one actually noted, but we are in 5G already. In theory, the essence of this wireless standard is about increasing frequency, which allow for greater data transfer, enable more simultaneous communication. But there is a catch here. As we move higher in the spectrum, the signal penetration decreases. So as we move forward, the network will remain a constrained resource. So for those like us in technology, it's essential to strategize about data transfer between computation points. This will always be a limitation. In the AI era, performance is not just about compute, it's about how fast we can move data as well. And we must remember that there are no true workaround from the fundamental law of physics, such as the speed of light. After all, that is a law. Now, because today we are witnessing a surge in, and this word is horrible for me, so you can read it anyway, but it's ubiquitous connectivity, I guess, with the immense computational power packed into very, very small devices. A unique consequence of more law is that outdated hardware becomes extremely affordable. And we see this trend unfolding in industries like the automotive sector, right? Car makers who in the past didn't like to spend much on fancy computer stuff are now adding mobile internet features to the cars. This enabled continuous telemetry back to the manufacturer, ensuring that they're always in the loop about the car usage. So we can say that a car is no longer just a mechanical system, it's actually a data center on wheels with hundreds of sensors, AI chips, and connectivity to the cloud. Today, car doesn't just move, it actually thinks, learn, and update itself in real time. So if we step back a little bit, we find ourselves in a new era. While it might not be entirely post-pandemic yet, we are beginning to discern a path forward. And through this transformational period or transformative period, the role or the indispensable role of the technology in virtually every facet of the human life has become even more apparent. We are embracing an overwhelming digital world. This digital evolution touches every corner of our life, how we work, how we learn, relax, care, worship, and how we engage with society and community. In this digital era, we're still amazed by the cool things that technology can do. The non-stop push to produce innovation, discovery, and growth. As the Intel CEO really rightly put it, we are being propelled by the technology superpowers. They call it, he called technology superpowers, These foundational technology are reshaping our world, bridging the gap between the tangible and the digital. They allow us to simulate and create digital replicas of everything around us. Consider compute, the first one here, as one of these superpowers. Since probably 2004, there has been a big push to computing capability into everything that we do. The emphasis of connectivity has made that everyone and everything is connected or interlinking, which is the second superpower here. Our infrastructure now boosts the limited scale of the cloud, but increasingly the edge also offer unmatched reach in terms of capacity, low latency, and bandwidth. Then there is the AI, which basically takes or turns vast data into actionable insight. And lastly, the sensing, ensure that all we compute and connect become increasingly perceptive. Each of these 5 pillars that we are presented here is transformative on his own. For example, enhancing sensing will require more computing, which in turn is going to demand more connectivity. And as we expand connectivity, we need broader infrastructure. And with more data over this infrastructure, there is a surge in AI application leading to new use cases. So these pillars that we showing here actually reinforce, accelerate, and empower each other, promising to unlock even more profound possibilities in the future. We can call it this one like the flywheel of innovation. And it's the issue, or not the issue, but the thing or the reality is that it's spinning faster every year. An interesting takeaway here is that these technologies are no longer siloed. They are becoming an integrated system of intelligence that is embedded in our environments, industry, and even ourselves. So as technology continues to evolve, it doesn't just change what we use. It actually redefines how we live, how we create, and who get access to. We are seeing a world where product become platform. Ownership gives way to access, and scarcity turns into abundance, at least for those who are ready. Those forces is again, very difficult for me, this word, but you can read it too. Dematerialization, demonetization, and democratization. And together with that, high scalability. These are reshaping industry, disrupting career, and unlocking opportunities on a global scale. I represent this one for the question 3DS to X 10X, It's not a formal equation, obviously, but it's just to represent that these forces are combining. And the interesting thing is that, first of all, the opportunity are on a global scale, but second, the question is no longer if this change is coming, it's how we actually lead, how we adapt and try in this new era of abundance and acceleration. So that's the first part of the talk, which is purely around the technology, which is one of the biggest enablers that mining is taking advantage of, which I'm now going to move to how mining relates to these things. So mining has always pursued innovation, believe it or not. Sometimes people reflect that the adoption in mining is very slow, which can be, but they are always pursuing innovation. But most of the time, in the last 100 years, probably is largely through the lens of physical productivity. So how to move more material more efficiently. Now, but today opportunity and the challenge, to be honest with you, is different. It's not just about doing more, it's about knowing more, deciding faster, and adapting smarter. Technologies like autonomous vehicles, sensing, cloud computing, and AI have given us the tools. What's needed now is to completely rethink the mining operating model. One of the important points here is that we need to start to treat the data as a first-class asset, which is integrated across the silos and enable intelligent action from the pit to the boardroom. And remember, we are not just digitizing mining, because mining is moving away from how well the operation moves material towards how well it gathers, analyzes, and acts on data to move the material more productive. And a couple of examples on that, through the Industrial Revolution, obviously it takes a lot of time, as we saw in the first slide, but it often takes many years for a technological breakthrough that such revolution make possible to be properly understood and the attribute exploited. For example, the long-term impact of the second industrial revolution on mining and mining productivity can perhaps be appreciated by the mining equipment. You know, in here I'm presenting a mining equipment of 1915, which basically the capacity was 7.5 short ton. Then we moved 15 years and we got the new model AP, which increased from 7.5 to 25 tons. And in fact, if you really look over the time since 1900 to the 2010, you're going to see another exponential graph here, where it's very sticky hockey stick graph, which you can see a very flat progression over a lot of years, but then start to ramp up. And as you can see, probably around the 1970, the capacity of the track start to push that boundary more and more. And today, you can find this little boy here, you know, which is huge. As far as I know, this is the biggest track in the world at the moment, which is the Belas, which is built in Belarus, which is basically has the capacity to move 450 metric tons and actually up to 64 kilometers per hour with an investment of anything between $6 to $8 million. Now, the most important thing is that actually consume 1,300 liters per 100 kilometers. Let me just check. Oh, thank you for the confirmation. Yep, it's massive, right? But the reality is that we are touching the limit of the physics too. So we really need to think about different. Another example on the same aspect of is what happened with the drilling machine, you know, and I'm taking this picture, which is really great picture, actually. It was done by Atlas Copco, that now is Epiroc. This is 2005, actually. It would be really good if they can continue updating this one. But, you know, here you can see the progression in the mining equipment, particularly around the drilling, you know, and it's quite amazing to see, and actually more extreme than the track capacity, how the performance went up in a very short period of time. Again, probably in 100 years, they went from 3 to 5 meters per hour to close to 450 meters per hour. And if you think about these days, everything is thinking from the perspective of autonomous perspective, you know, again, rethinking how we operate in these conditions. What about from a technology perspective? Well, you know, if we really think about this one, and I just want you to put the focus on the pink contribution, which are the enabled technologies. You know, if you really think about all the mobile PC, the 3D software, GIS, GPS technology, is probably around mid-90s. That seems like a long time ago, but in reality, it's not, you know, because even though the technology was there, the adoption took a lot of years too. Now, these days, you know, everyone got 3D software, you know, everyone got GPS on it. But it wasn't like that. And in fact, UIV is becoming old these days too. It's interesting to see how these technology are being used, adopted in mining, and how they help to the mining operation to become more productive. In fact, the next graph that is here, you can see how these key technical innovation are being affecting the dollar per ton. Okay. And this is a really nice graph from Minex Consulting, which, you know, is connecting technology or innovations in mining, how they're being tracking from a costing perspective. And as you can see, automation, which is probably where we are pushing at these days, you know, is trying to get not just more productivity and more efficient, but also more safe, which is really good to see. Another aspect in mining is that it takes a long time to, you know, open a new mine site, really. You know, it was a study from SP Global that was delivered or updated last year, where basically it takes in average 16.3 years from the discovery to the production. that's a lot of time. So, you know, and if you really think about it, there is something here that need to be understood and improved, because as we move forward, still there are necessity to explore and exploit more mine size. So 16.3 years is quite a big period of time. In fact, if you can open that one by different commodities, I hope that you can see that picture there. You know, it's not very different really for the commodity. And even it's not very different between underground and open pit. Of course, there are countries that are better than others, but in general, it's not gray. You know, there is, in this particular study was 136 mines, and you can see, you can go from on the top 22 years, almost 22 years, to probably the last one there, which is Laos, which is 11 years, you know. So what's the reflection here? The reflection is that as we move forward, we really need to think about how we can reduce this time, because the reality is that we're going to need more mining anyway, you know, and we are already at another pivot there, that we are going to need more copper or critical minerals that we need. And if it's taking, you know, an average of 16 years, that's not going to make it. So there is a challenge for us as an industry to put the head on and do something about it. Now, from a technology perspective, there are, I am convinced, or we are convinced, you know, that the mining industry is probably 10 years ago in a clear inflection point, you know. Digital technologies present an unprecedented opportunity to manage variability more effectively and actually boost productivity. Now, the momentum for adopting this technology basically are four digital technology clusters, which are growing very rapidly. Among these three is the data, is the connectivity data, computational power, and connectivity. And I'm gonna put this one in context, you know, all around data. So this is the graph of the data that we are generating per year. I haven't updated this one, but it still is valid. It's quite interesting to see the data that we generate in 2022, which is sitting here, 97 zettabytes. The data that we generated every day is more than the year 2007, you know. So the average data that we generate every single day is actually more than the whole year 2007. The growth is exponential again, it's massive, which is a reflection of what we've been talking here. And miners already produce huge amount of sensor data, potentially enable them to obtain a more accurate and consistent picture of reality. You know, it's an opportunity that is closer than ever, and we need to embrace it. The second foundational technology that I'm going to put the focus on, which is the analytic and intelligence. The realm of analytics has seen remarkable advancement from the rise of machine learning to enhance statistical techniques for data integration. These innovations transform vast data set into insight about the likelihood of future occurrence. Now, complex mining tasks, including geological modeling, day-to-day scheduling, and predictive maintenance, are now increasingly governed by sophisticated statistic and optimization algorithms. As an example of what we're doing, we got Maptek domain in CF, which is, you know, a commercial off-the-shelf product that I believe that you've been using it, I think, in the university, but it's basically, you know, neural net that allow us to predict the geological domains. This is an example in how we are providing product to the mining, utilizing or taking advantage of this foundational technology. There is an example that was presented by IGO, which is the example that I am showing at the moment on the screen. You can download it from our website if you want to read it in more detail. But this is the use of, the machine learning models to increase the prediction, in this case, of and basically the interesting thing of this study in particular is the comparison against the different methodology as well. What is called here artificial intelligence is basically the result of the domain NCF. You can go and dive in more detail if you want. Geospatial management is another example of how we take advantage of these two foundational pieces, the data and the advance in processing, which, is one of the latest products that we released in the market 1 year ago, if I'm not mistaken, which has allowed you to constantly feed data into the system and calculate the end of period at any point of time. You record all the information to become the single sort of truth for us from a survey perspective. I invite you to explore that one later on too. So that's the example in how we are, utilizing or leverage this foundational technology. The number 3 here, where's my mouse here? Yeah. The number 3 is human-machine interaction. And, as we discussed before, the rise of consumer smartphone and other mobile device have revolutionized how people communicate, not just with each other, but also with machines. And these innovations are not limited to personal use, and their applications are rapidly expanding into the industrial domain. For instance, consider the smart glasses that provide real-time instruction to assemble line workers or technicians performing equipment repairs, thereby enhancing the operational precision. Another interesting innovation here is work when we equip equipment with sensors. These start to transmit critical data to management about potential hazard or environment conditions, and checking the physical well-being of the worker, leading to enhanced safety measures in place. And there is also robotics, advances are making in fully autonomous equipment, which are both more affordable and efficient. It's very interesting because since 1990, the cost of industrial robot in manufacturing has decreased by 50%, whereas the US labor cost has surged by 80% on the same time frame. So we're at a point where we can actually start to leverage these technologies more and more. Simultaneously, technology breakthrough in fields like artificial intelligence are elevating the capability of this robot, leading to a broader and more sophisticated applications. In the mining sectors, there are growing trend in employing teleremote and assisting control tools. Moreover, the integration of fully autonomous equipment is becoming prevalent in processes like haulage and drilling. What we got in that space? Well, we released 2 years ago Vision V2X, which is basically a proximity detection system that allow us to help with the safety in an underground environment. As you can imagine, in underground is very challenging because it's very difficult to have infrastructure around it in order to make sure that everyone is aware of everything around it. Well, this technology allowed to improve that, and we've been pushing this in the market in the last couple of years. But not just Maptek, to be fair, everyone, as we take advantage of these technologies, we are increasing productivity, but also making the workplace safer, which is very important. And the last foundational technology applied in the mine value chain is around the advanced engineering. And I want to take basically attention in the renewable energy component of it. And, as you can see now, mine consume a lot of energy, and miners start to, not now, but from a few years back already, start to thinking that very seriously. As an example here, is basically a new solar plant, a Gudai-Dari, which is a Rio Tinto operation. They got a 34 megawatt solar plant, together with a new battery electric storage system at ton price. The idea is to reduce the annual carbon dioxide emission by about 90,000 tons, which is if you compare that one, what that actually mean is probably around the same amount of produced by 6,000 homes in Australia every year. And just to be clear, I don't have any relation, I'm just using examples in the market to highlight how the industry is pushing these things too. The same thing applies for other Australian company, Fortescue. They got a hub of different operations, and it's interesting to see now how the energy infrastructure is a combination of different things, not just one single technology, but, is how you leverage all of them. And I guess an important aspect of it is that mining engineers are crucial to the renewable energy future. But unfortunately, the industry is plagued by negative perception, such as fossil fuel dependency, physically demanding, or very difficult working conditions, lack of workforce diversity, and more than likely or not, having to live in remote towns, and lack of sophisticated infrastructure. So the transition to our renewable energy future required the involvement of young people like you guys, who are passionate about environmental management and sustainable development. In fact, I put a quote there in the slide, that just keep in mind, to meet the demand for electric vehicles and energy storage batteries alone, we need to open approximately 250 new copper, nickel, lithium, and cobalt mines. It's a massive thing. And that's because we really need to continue be part of this industry as well. So collectively, all these 4 pillars, let's call it pillars, these technologies help us with a pivotal change in mining operation. This transformation is characterized by both the utilization of information flow to minimize the inconsistency in the decision-making, and the adoption of more centralized, mechanized processes to decrease variability in execution. In our perspective, the most profound impact will be realized when these technologies are seamlessly integrated across the entire mining value chain. And just to be clear, I'm taking this one from a McKinsey study, which is really interesting to read. And in that study, they identified 5 areas that can potentially create significant value for the miners, which is this picture that I'm presenting here. They basically presented in 2 aspects: better decisions and safer and more consistency operations, the second part of this graph. And I'm gonna try to go from every box and give you some example in how we do it or the industries do, So let's start for the deeper understanding of the resource base here. So there is no question that excites more to the mining people as much as this one, What if you knew exactly what was in the ground and where? That's the holy grail. Now, the journey of developing resources insight from exploration to short-term mine planning often span multiple organizational boundaries, diverse data sources, and various geological models. Today, the miners can enhance their resource knowledge by merging ore body model information with blast hole drill data and online sampling. We got a statistic techniques applied to the exploration data that can increase the probability of discovery and better direct subsequent drilling for optimal information retrieval. Integrating geological information into a single superior source of truth can optimize drilling and blast pattern, facilitating the execution of the mine plan, and obviously reduce the quality issues. From a Maptek perspective, we got Maptek Blast Logic, which is our drill and blast management system that allow us to digitize the information on the bench. It allows you to capture the data and actually reconcile against the execution and improve over time, particularly to support that first box that I was mentioned before. The second box is around optimization of material and equipment flow. At its core, the mining supply chain are intricate system comprising various pieces of fixed and mobile equipment. While tools and metrics such as the overall equipment effectiveness provide a foundation for operational improvement, they don't capture the entire system complexity. The push of real-time data and superior analytical engines is paving the way for scheduling and processing decisions that maximize equipment utilization and yield. For instance, in open pit mines, integrating traditional dispatch with intelligent algorithms can enhance the machine efficiency. From a Maptek perspective, we've been working since 2014 with a scheduling package, which actually use a different technique, which is kind of, it is an evolutionary algorithm, which is based on heuristic and has the potential to accelerate or explore in a more efficient way the solution landscape, giving you high quality solutions in a very short period of time. Of course, doesn't guarantee the optimum, but essentially allow you to provide or give that trade-off between optimum and speed, and give you the opportunity to analyze more in a very short period of time. Because one of the features in the algorithm itself is that rather than to run a single thing, you're running multiple schedules in parallel. And the more important thing is that not just running parallel, actually they are learning between each other, which allow them to converge in the solution landscape quicker. We can talk a lot about this one, but as a high-level example, this is one of the tools that we are putting in the market for people to take advantage of it. The third aspect of is perhaps in processing plants. Many operators struggle to choose the different factors that influence the yield. There is an opportunity here by utilizing new mathematical techniques that identify hidden correlations among secondary and tertiary variables. In fact, there are some examples out there where people has observed improvement in plant yield of gold, nickel, and other minerals by 3 to 10% within just a few months. So there is an important aspect of it. What we got there, well, Maptek got MRT, or Master Result Tracking, which is our material tracking and reconciliation system, which has the ability to connect the ore body modeling to the final destination of the material, recording every transformation of the data that allow you to reconcile back. Again, it's another example of the technology that can support that particular component. Then we pass or move, I said, to the safer and more consistent operation, the second part of this graph or this picture, and we're going to be talking a little bit about improving anticipation of failure. As we mentioned before, mining companies accumulate a huge amount of data from the drill, from the track, processing plant, and trains. But still, the information is underutilized. There is a study done a few years ago when they demonstrate that probably less than 1% of the data from their equipment is actually utilized, which is a shame because we're collecting so much data there. But we got an opportunity to utilizing this data to predict the likelihood of a specific component failure, for example, rather than to thinking about from the traditional time-based approach. We can actually reduce the maintenance costs and avoid an unexpected disruption that impact the production. Another example here is increasing the mechanization through the automation. That's another big aspect of, and automation holds the promise of lowering the operating costs, enhancing operating discipline, and safeguarding the workers. Some technologies, such as the automated haulage and the drilling, have reached the full-scale commercialization, which is really good, while others like automated blasting and shoveling are still, in testing phase or getting some good results so far, which is really good to see. Now, the financial prospect of the automatic haulage are very robust. There are studies there that they are cutting the total ownership cost by 15 to 40%, particularly around the labor cost, and that can be huge. But nevertheless, miners must make critical decisions regarding pit configuration, equipment setup, and operational transition in order to fully embrace that technology. So this is a picture of this, the Gudai-Dari fleet of autonomous haul truck allow them, Rio Tinto, actually, to operate equipment and vehicles remotely from Western Australia, from Perth, which is, a lot of kilometers away from that, improving safety and efficiency. And again, I've been using some picture of different mining company. I don't have any relation with them. It's just I found interesting to share it during this presentation. So full disclosure. So, we got these 5 areas of digitization where we got an opportunity to create a lot of value. And there are some example, probably this is another example in how we Maptek can improve safety as well. We got Maptek Sentry system that allow us to monitor in real time, 24/7 to ensure or predict or, highlight potential problems in the pit. And you can explore that one in the website. Now, as I mentioned before, I think capturing the value from the digital innovation represents a fundamental shift in vision, strategy, operating model, and capability in the mining industry. In particular, much of the value creation in mining will shift from how well the operation move the material to how well it collects, analyze, and act on information to move material more productively. This will be a difficult change. Okay, but it's only going to be done if there is a big prize at the end of it. By the way, one of the things that we are working very hard at the moment is in our Maptek Cloud ecosystem. The first release is going to be in July this year, which is essentially trying to provide a mechanism for us to store in an efficient way the data, but also trying to leverage all the mining algorithms available, not just from us, but also from the customer perspective, and ideally orchestrate the processes moving forward to actually take advantage of the data that we are collecting. This is something that is coming for us. But let's go back to the big price of it. If we really focus on these areas of improvement, there is a big price of it. In fact, in this study that I am highlighting at the moment, or I'm using as a base, is I think it's 2015, so it's a while ago, and actually they were predicting by 2025, which is this year, which is really good to see if there is going to be a follow-up of that one, that the big price is going to be probably, or the impact, the economic impact is probably around 370 billion per year by 2025. And if you focus on, there are 2 major areas of value creation, which is in the operation management, particularly around the deeper understanding of the resource base, but also the optimization of material and equipment flow, obviously the increasing mechanization through the automation and the monitoring in real time performance versus plan. That's the biggest chunk of value creation there. But also in terms of the equipment maintenance, and improve the anticipation of failure with all the data, improve the predictive algorithms and put it in practice. Reduce the unscheduled breakdowns, and obviously taking care of the machines allow us to have a longer equipment life. This is an example from Freeport-McMoRan. As you probably are familiar with, Freeport-McMoRan is a big mining company. They got a lot of mine sites, particularly in the Americas. They got in Indonesia as well. They wanted to get more copper without opening new mines, which we discussed previously that it takes a lot of time to put one mine up and running. So, which, as I said, it's expensive, taking a lot of, and takes a long time. They thought that using advanced data analysis could help, but they didn't know how to use AI on a big scale. So basically, Freeport worked with McKinsey to use the data and AI to improve their mining operation. They focus on mining in Arizona, which is called Baghdad. And they aim to create a digital tool that could be used in all their mines. So this was like a proof of concept. One of the important things for Freeport is that they already have a cloud system that collecting the data from sensors on the equipment. So that's a big step. And just to put this one in context, I think we are talking about probably 2019, 2020, this case study, okay? So McKinsey made an AI model to help them to find ways to increase production without spending more money. That was the idea. Now, the results were phenomenal. With the new AI, Freeport now could adjust the mining processing every hour based on the type of the ore that they were working with. This only change, rather than to define the set point for the processing plan for the chief, now they are adjusting per hour. This only change produce between 5 to 10% more copper right away. That's a massive improvement. And as you can see, there is 200 million increase in pounds in annual copper production across the mine. And you put straight away 350, half a billion and EBITDA improvement by scaling the AI. And particularly when you compare this one to processing a new, the cost of the new processing facility, anything between 1.5 to 2 billion, this is a huge win. So in the long run, the extra copper they could get using this AI is like having a new mine without waiting for the, the thing that we were talking before, the 16 year. And obviously this model, I don't know if they continue to put it in the different mindset, but, as part of this proof of concept, it was proven that the technology is there and mining companies could leverage that one if they want. Again, this is good idea, and I bring this one to the attention because, I'm not sure if you're familiar, but this is being known like the mine of the future. Rio Tinto has been spending a lot of, I guess, a lot of time and money and energy to get this one up and running, but it's quite remarkable the number of technology that are in place. Gudai-Darri is probably around 110 kilometers northwest of Newman in Western Australia. It's a remote mine site, in the heart of the beautiful Pilbara regions in Western Australia. But I just put a bunch of different technology that they are embracing and leveraging in that particular mine site, which is, again, is quite remarkable. And they are getting really good benefit of that too. They increased the capacity of the mine last year. I can't remember on top of my mind the amount, but it was sizable, the increase in productivity. So the majority of the mining company are going to start to looking at using technology to automate and connect all the activities, from the digging up the raw material to selling the finished product, really. And this big connecting system, which is very simplistic in this diagram here, but just an idea to reflect on the number of technology that you can see there, it's going to allow us to, work safer and be more efficient. It's not fully there yet, many of this technology, but, as we discussed early on, it's just a matter of time before it happens. This whole process, which people refer to the mining value chain, is super important. Companies that manage it well can get ahead of the industry, really. But in the past, many companies just focus on one part at a time, like mining, shipping, instead of the whole picture. It was a lot of local optimization. I think today the opportunity is to step back and actually trying to mimic that complex system, because there is a lot of relationship or things that are going to emerge for the interaction of these different areas. And another aspect of it is the Internet of Things. As we got more devices, as we got more technology, and we are sensors that are connected, then obviously the integration of the physical device and everyday object allow us to capture and communicate and interact with others via internet. And they can be remotely monitored, obviously, and controlled, and there is plenty of examples today. In the mining industry, the IoT has emerged as a tool to optimize costs and productivity and enhance safety protocols and advance artificial intelligence applications too. Now, particularly the declining in the sensor price, coupled with enhancing computing power, are facilitating the broader adoption of the IoT through the mining value chain. The key component is harnessing the data from this device to boost productivity and efficiency that can currently lead to reduced emission, bolstering a company environment, social and governance, ESG credential as well. And that's an important aspect of it, I cannot conclude this section without addressing or talking about ESG, environmental, social, and governance. And actually, in here, we got the result for 23-24. And ESG is still top of mind on this EY study. ESG stand out as the paramount risk and the opportunity for mining and metal companies. This significant has become deeply embedded in corporate strategy, given its profound influence on nearly every facet of the operation. So many challenges related to ESG are not new, really. And for instance, making a stride in diversity or equity and inclusion remain a pressing concern, while mine closure and rehabilitation demand a more strategic and long-term perspective too. This is an important aspect. I think from one year to another, they change the order, but it still is top of mind. ESG on the top, ESG on the top, ESG on the bottom. And the landscape of the ESG is evolving, miners now need to address emerging concerns and expand their competence to manage them properly. Issues like water stewardship and biodiversity are rapidly escalating in becoming very important, particularly in the context of the climate change. Stakeholders are urging miners to more truly evaluate the risk and opportunity and combine this insight through transparent, outcome-driven metrics and assurance. In fact, more rigorous reporting will become critical if companies are to meet growing stakeholder expectations and avoid potential accusation of greenwashing. Miners that achieve this can get actually an edge of competitors in many ways, from accessing capital to security license to operate and attractive talent as well. So it's a big aspect of it. And particularly because mining is very special, because doing it right the first time is critical in a non-renewable market. if you really want to deliver long-term value. Unfortunately, in mining, there are no second chances. We mine once, and then we move the material from point A to point B, and there is only one opportunity to make the right decision. Particularly because these resources cannot be replaced after they have been depleted, which, is a huge concern for humanity because we actually rely on them to meet the majority of our needs. And that's where you guys come in, because, unfortunately, enrollments in mining engineering have consistently declined over the past decade in both Australia and US. Moreover, in Canada as well. This study that you got here in front of you was basically done in Canada from Jan Talent. And as you can see here from mining, the 42 and the 28, so that gives us what, 70% of the people in this survey, which is between 15 years old and 30 years old, they definitely will not, or probably will not, consider working in mining. So getting access to the new generation of people working in mining is a big challenge. In fact, in Australia, it's very concerning because the job vacancy in mining had more than the double since February 2020, and there are projections that suggest that probably in Australia we're going to need 24,400 new workers by 2026, which is not far away. And it's only forecasted that probably we're going to be able to supply 16,000 during this period, suggesting that job vacancy in Australia mining will likely continue to grow. And, it's quite amazing to see how technology is been moving in the last 50 years. And it's been really good to see how mining are embracing that technology. But there is an aspect of it that creates some issues down the line. If we are not responsible in how we apply the technology, and more importantly, how we capture and manage the data that we generate. And I'm going to talk about, the concept of the dark data, which is basically the information that we save online and then forget about, even though we may think it's not a big deal, keeping this data stored use energy, because actually is in a server and the server need to be on. It's a common misconception that if that digital data is carbon neutral, but actually in 2020, digital activities cost 4% of the global greenhouse gas emission. And companies should think about that, how they can handle the data to be better for the environment too. A lot of the data that we save is only used once. This could be many similar pictures in our online stores, or different work that we continue, creating and storing in different shapes or versions. Storing all this dark data require big building full of computer, which use a lot of power. So many companies don't realize this, and why it's important to remember things for the business. We should also think about how this practice affects the planet as well. As many organizations strive for net zero carbon emission, the focus typically lies in mitigating with conventional carbon source, like offsetting emission through third-party initiative, like a tree planting or whatever. But yet, while much attention is centered on limiting emission from sectors like automotive, aviation, and energy, the carbon footprint of digital data processing is on par with this industry and is growing. The surge in digital data production is relentless. And this year alone, we're anticipating 97 zettabytes, which is equivalent to 97 trillion gigabytes of data. And by 2025, by the end of the year, we are actually doubled that to 181 settable. So considering these big numbers, it's surprising that this hasn't been more rules or attention on reducing the digital carbon footprint on organization. I guess to address this growing concern, there is a concept of digital decarbonization too. By this, they are not referring to the use of phones, computers, sensor, or other digital technology to shrink an organization carbon footprint. Instead, is actually emphasizing the need to diminish the carbon footprint of the digital data itself. So it is crucial for us to understand that while digitization itself is not harmful, inherently harmful to the environment, the environment consequences are substantial based on our daily digital activities in the workplace. Just to put you an example of what we're talking about, the severity of the dark data dilemma. Data centers, which account 2.5% of all human caused carbon dioxide emission, surpass the carbon footprint of the entire aviation industry, which stands for 2.1. Just think about that. It's massive, which means that we got a massive opportunity to help in that regard as well. As an example, take, for instance, a typical data or a typical business, really, such as, insurance, retail, or banking. A company in one of these sectors with 100 employees could generate approximately 3,000 gigabytes of that data daily. If we were to retain this data for a year, the carbon footprint will equate to probably 6 flights between London and New York. Now, you may think, okay, that's not too bad, but that's one business of 100 employees. Now, in today's business landscape, collectively, they produce 1.3 billion gigabytes of that data each day, which is, if we do the calculation, it's around 3 million flights from London to New York. It's a lot. There is an opportunity for us and rethink how we store as data too. So what is next? I'm gonna move a little bit though, trying to think about moving forward, what we can expect. The key question here, what's gonna succeed the smartphone, obviously. Right now, most of the people mainly use the smartphone as the primary computing device. But the reality is that seems like a smartphone haven't changed much in the last years. In fact, the smartphone from where they are to what they are today is really probably you go more cameras, you go more storage, but the functionality itself hasn't changed too much. At the end of the day, continue to be a flat piece of black glass, really. The natural successor of this one is probably the AR headset or a pair of glasses. Although this picture here is just a mock-up, it's not real, and it was some push to build this one. Actually, they stopped it, so they didn't progress with this idea. Apple didn't progress with this idea. They move away from that. And as we are going to see it today, but it seems to me that the AR probably is going to be the replacement of the smartphone shortly. In fact, we got commercial companies today. They are offering glasses with camera, although the quality is not great. I mean, it's a matter of time that they're going to get better. But Apple pivot to what we call the Vision, or what they call Vision Pro, right? And they launched this one in 2023. So it's a couple of years there. I don't have one of these, but I heard that it's not been very successful yet. But again, it's a matter of time where, we are going to start to see these things more useful, adapt more or we are going to adapt better to these kind of devices. But what is interesting here is the computer power of these things. I mean, we're talking about 3.5 teraflops, which is a huge amount of computer power there, that surely we're going to find use cases to use it at some point in time. And in fact, there are companies that are taking this technology to potential use cases. The HoloLens has emerged as a potential AR solution, but the current trajectory is uncertain at the moment. I think this picture is from Trimble, but I think Microsoft bought it anyway. You can buy those things. I checked this one last beginning of the year, and still you can buy the thing. It's $5,000, and you got an operating cost of $1,000 as well, which is quite large. So it still represents a significant investment. Now, it can be justified for some industry, absolutely, probably like construction, but still there is some, it needs to be some progress here to actually adopt this one more widely. Now, the potential is huge, okay? The potential are really promising, actually, particularly in industrial context, the ability to make equipment transparent, maintain light checklists, and continuously record video during maintenance are all these compelling use cases, as it's trying to represent in the picture there. There is a parallel between what is this AR glasses today and what it was the BlackBerry phones in the 1990s. Not sure how old are you guys, but I definitely lived that transition, and it was really expensive to have a BlackBerry at the beginning, because it was a revolutionary idea. You can actually check your email in your phone, believe it or not. Today, it's the same. It's the normal aspect of it, but that's how the progression goes, really. Anyway, obviously, we are in the middle of a big change as well in terms of AI. There's a lot of information in the market, I would say. And it's actually revolutionizing nearly every sector and category of the computing. Now, to really understand how big this change is, it's good to look at the main feature, which is, our understanding and innovation. And this shift has two dimensions, or it manifests in two different dimensions. The first one is related to the user interface. If we trace the evolution of computing over the last 70 years, there's been a consistent effort to achieve human-computer interface that are increasingly intuitive and natural, And we witnessed that change from the graphical user interface to the introduction of the mouse, and the keyboard that you can communicate with the computer. And that was revolutionary at that point in time, and it reshaped our interaction with computer. But then moving forward is the multi-touch technology, that you got in the smartphone, and you can just touch it, and select what do you want to select. That create another major paradigm shift on that. But now we are in the cusp of the next significant leap, which is the natural language. And using natural language as our primary mode of interacting with computer, as long as it's been a long aspiration. And today we have the opportunity to incorporate this across every application and interface that we design. And not just, communicate it from a natural language perspective, but also you can actually talk to them with many of them, which is awesome. Now, the second dimension is around the information management, because essentially the overarching goal of computing has always been to digitize entities. These entities, people, places, things, and trying to get meaningful insight from them. In essence, most of our effort has been about turning things digital and trying to understand them. And today we are equipped with a newfound capability, which is the reasoning engine. And this tool provides us with a foundational blueprint for any task we aim to accomplish. It offers a predictive insight and deepen our understanding of complex systems. So in summary, when we discuss AI, and by the way, you need to be careful when you see, AI everywhere, because as soon as you see AI, probably it's a technology that doesn't work. They need to talk about what is the technique that is behind it. What is it? Are you talking about a natural language processing? Okay, let's talk about that. Or are you talking about neural net? Okay, that makes sense. But when we umbrella everything around AI, I would be suspicious. But it's interesting for us to recognize the contribution here, a more organic or natural interface via natural language and a powerful reasoning engine that superchain our data with processing capability. These are the pillars upon which we should anchor our understanding moving forward. And there is another interesting change here. As we start talking about, this exponential growth from the Moore law, a new usage of Moore law has been emerged, which is the ability of the increase in size of the model, instead of the parameters, how many parameters every LLM is managing. And as you can see now, rather than to be twice every 18 to 24 months, now we are actually experimenting growth in 10 times, 10x. In here is a picture until 2021, but the last model, which is GPT-4, I think that's what we're at the moment. I think has a total parameter 1.70 trillion of parameters. So it's huge in scale, which means that now we are increasing exponentially, but times 10 now, more than before. This is the same picture with another models in the chain. So I'm not going to spend too much time on that. But it's also important for us to reflect, training one of these most popular models, LLMs, use the same electricity as watching more than 1.6 million hours, and if you calculate those things, it's a lot of streaming there. But I guess, more tokens equal more computing cycles, which increase the cost, which, believe it or not, or we like it or not, is creating more carbon emissions too. Look, not sure how this is going to work, but essentially one of the aspects that I'm very interested with the LLM is with the spatial reasoning and the comprehension of the model. There is a lot of debate on this one. I'm going to make it really quick here because we're running out of the time, but essentially, you provide this prompt to ChatGPT 3.5 in this case, and most of the most of the responses are wrong, okay, because that model doesn't have the spatial reasoning in place. And it's basically around if you are in the middle of a room, and you got different people around there and in different positions, you start to ask who should be in this position, and essentially 3.5 fail, But with the GPT-4, not even the 4.0, which is the model that most of the people are using, you start to see the right answer to this problem. So start to understand, because for us as human beings, if you see the picture, it's really easy to respond this question. But from a model perspective, you really need to understand the relationship between them in order to provide a correct response. And, ChatGPT-4 actually is showing or start to show huge or good capability in reasoning, which is quite remarkable as well. And not just on that, it's also about visual analysis and contextual knowledge. Again, a couple examples you can explore later on, but essentially trying to ask questions, and he really need to understand the picture itself to provide the answer that he's providing, which is really good to see. But not everything is good, you know. As you know, at the end of the day, these are models, you know, and the model has some, it's important to understand the limitation of the model. And one of the limitations for LLMs is the hallucination, which is basically incorrect or misleading result that the AI models generate. And I put a couple examples here that are all fake, really. But, you know, it causes harm, you know. It was a ChatGPT wrongly accused a law professor of sexual assault, you know, which is obviously not correct, but it's part of the things, you know, it creates things and people read it and believe that it's true. But also, you know, people like Scarlett Johansson, which was shocked when, you know, some of the chatbot imitated her voice. And this one is quite really interesting, you know, chat box with Air Canada, which I encourage you to read it. So all these are examples, you know, that we need to be careful with the technology. As usual, you know, there is no silver bullet here, you know, it's a model, and most of the model are wrong. Some of them are useful, right? And this battle is going to continue now. You know, we go forward, which is part of another presentation that I'm preparing at the moment. But, you know, we got 4 big players at the moment. You know, we got Anthropic, which is a lot of people is using it this day. You got XAI, which is the Grok embedded in Twitter, what X is called now. You got OpenAI, and then you got the Cohere, which is the DeepSeek, or the Chinese one. This is going to continue, and, you know, there's a battle to be seen there. Now, I personally use Perplexity. I highly recommend that one. And from my perspective, the good thing about that one is that it provides the citation, where is the information coming from, and obviously it's your responsibility to check that one. But also it gives you some follow-up question about what you are asking or the interaction that you're having with them. So, you know, my personal recommendation is Perplexity. How we are integrating these things in Maptek? Well, you know, our online help, we put a chatbot, which has an LLM, which was trained with our data, which allow users, and this is online, is public, it's available, everyone can interact with that one. It's in a beta format, so people need to understand that too. But essentially, you can put question there. I put an example, as you can see, create a script to export 00T to OMF file, and there you go, you got the script, and you copy, paste, and run it. So you can interact with the Maptek Python SDK. And again, I encourage you to go there and have a play with it. I think a reflection of this one, and just is I really like this quote from this professor from the Harvard Business School, which, you know, AI will not replace human, but humans with AI will replace humans without AI. And that's the reality of it, because there is so much augmentation that this tool can provide to the human beings that if you don't embrace it, you're going to be left behind. And in mining in particular, there is a lot of potential here. You know, this is a matrix from Global Data where, you know, based on the different aspect of the mining value chain, you can see where you should invest in the things. You know, I'm not going to go into detail here, but you can explore it later on. Before we conclude, let's talk about another fascinating topic, which is moving forward, which is quantum computing. You know, always capture the audience imagination. Actually, quantum computing can be seen as a supercomputer. You know, however, it is not intended for general purpose computation, but for highly specialized tasks, and that's an important distinction. Just as we have huge supercomputer designed for a specific task like weather modeling, quantum computing actually excel in certain application or problem areas. What you got there on the screen, this one here, is the Sycamore computer, which actually has 54 qubits, and actually claim or had a distinction to be called quantum supremacy, because they solve a specific problem that is actually requires 1,000 of years using traditional computing method. And it was able to achieve with 53 qubit, because basically the day of the run, one of the qubit was broken or something like that, was malfunctioning. So, which is quite remarkable, because now problems that you can actually solve in a reasonable time frame, now you got the opportunity to do that. But it's important to also understand that there's a limited number of problems that this kind of computer are going to be useful anyway. Microsoft in February 2025, this year, so it's here, they released the first Microsoft Majorana, I think it's pronounced, which, is the first quantum chip powered by a new topological core architecture that is expected will realize the quantum compute capable of solving meaningful industrial scale problem in years, not decades, as it is today. So there is a lot of movement in this area. In fact, IBM has a whole roadmap on quantum computing. As I haven't updated this one for a couple of years already, but in 2023, they were ticking the boxes with the capacity of the qubits. I'm not sure if definitely they achieve Condor and Heron, what we're talking about instead of the qubit. You're talking about 127 qubits. But as you can see here, they are pushing very, very hard that angle at the moment. And one of the things that people start thinking straight away when it comes to computing is about the potential to disrupt traditional encryption method, which is true. But I guess there are other problems that are more interesting to solve, I guess, And one of the interesting thing is definitely chemistry. There is a lot of things there that can be useful for that. But another interesting problem, perhaps, is all the NP hard problems. And if you remember, the open pit mine planning problem is being defined as an NP hard. So perhaps there is an opportunity there, but that's something for another time of discussion. The thing is that, or the takeaway that I want to pass over to you guys is that quantum computing problems are predominantly revolve around deterministic issues, which bring the question is, how many quantum computers do we really need? Because the reality is, once the problem is solved, do we need to revisit it? Probably not. Unlike the non-deterministic challenges that require constant recalculation, like predicting the weather, deterministic problems have a set of outcomes, really, But, we are putting a lot of effort on that one. I think there is an opportunity, it's an exciting thing. And I believe we need to be watching very closely what we could leverage from that technology. This kind of scenario bring me to remember, Thomas Watson was when very early on in the days of the mechanical mainframe at IBM, when it obviously probably wasn't like this, but that's what the people, that's the story that has been over the years, is that once he mentioned in the board, that he believed, or he think that there is a world market for maybe 5 computers. And all of a sudden, when they released the first computer, they sold 25 in the first month. But, even though we're talking about 1943, right? It's very difficult to think about when you are thinking the computer this day were like this, to now when you got the smartphone in your hand, it's very difficult to envision that. And as we move forward, there's a bunch of different technology out there that probably is going to replace this piece of thing, as I mentioned, as I'm sharing now on the screen. So it's going to be an interesting thing. But bring the question, if you remember very early on in the presentation when we were with the Cray supercomputer, and all of a sudden, 26 years later, we got an iPad which has the same processing power in our hands, and we will normally work with playing what? Candy Crush, probably. You wonder what's going to happen now with the quantum computer. It's kind of the same thing. And probably, moving forward, we are going to, at some point in time, we're probably going to have that power in our hand. Not sure what we're going to do about it with that, but, it's a thought. Last year, I was very bullish on this one, and unfortunately, the technology didn't work, and I should remove this slide from the presentation, but it's here, so full disclosure. I thought that this was an interesting thing as a piece of technology. In fact, the whole pitch around this one is to change the phone. So rather than you have a phone in your hand, actually you got a device here that you can talk through, LLMs. But the performance was horrible. As I mentioned before, the constraints are in there, the delay or the latency between the question and the answer was horrible. You didn't have coverage, and plus. So anyway, I don't believe that product is in the market anymore. So when we ponder the landscape of the future, one truth remains evident here. While many attempt to predict what lies ahead, the most sure way to shape the tomorrow is just to create it. We just need to do it. And I think that responsibility and that privilege, to be honest with you, rests with each of one of you. I've been in the industry for 25 years. I am definitely running out of time, but you are starting, and I think it's exciting because the opportunity with all the technology that we got around us, the amount of opportunity that are going to be out there is massive. So as you continue on your academic journey over the next few years, remember that the knowledge you acquire and the innovation you foster will lay the groundwork for our collective future. I'm really, really excited and eager to witness the remarkable change you can bring to the world. And, with that, I just thank you for your time. This has been just a 2-hour presentation. If you want to get in contact with me, you can connect with me through the QR code, through LinkedIn, and I'm more than happy to open it up for some questions and comments and go from there. So thank you, guys.
Thank you, Eduardo. That was a lot of important and quite impressive information. If people have any questions and they are watching this online, they can type it in the chat. I have a couple of questions that we're discussing here with students. I remember a few decades ago, Eduardo, it was an issue with the compatibility issues between different systems, different software, as far as the data is concerned. Now that we have a lot of data, practically everything in a mine produces data. How are we doing on the compatibility front? I mean, are we still having the same issues, and how much of time and energy do we spend on that front?
For us as a Maptek, one of our strategic objectives is to ensure that we provide interoperability and interoperability with others, but integration between our products too. And it's one of the aspects that we're working really hard. In fact, Bestrek, which is the platform that we're building at the moment, is building that with those principles in mind too. So what that means is that you are going to be able to upload information, but that information will be available to be consumed by others. So I think that's an important aspect of it, and is an issue in the industry as well. Other industry has solved the problem, oil and gas, for example, and they create universal file format. I think in mining was an intention to do that one through the GMG organization.
Yeah,
you
the
know,
open mining format. Yeah.
That's right. And what we did, and we support that one too, by the way, because we did you can actually export our data in OMF at the moment. In version 1, I believe the version 2 is in testing. Obviously, when that version is released to the market, we're going to be able to update our system to ensure that people can actually transform the data that we're creating in our system and make that data available for other purposes as well.
The other question relates to the energy consumption of data centers. The numbers you presented were quite impressive, particularly the comparison with other industries and how much energy they spend. Do we have any figures about how much of that power consumption is related to mining activities when it comes to the data center?
Not in particular at the moment, but it's something that I'm gonna be trying to get for more data around that one. Yeah, that's an important aspect of it. Not sure.
Okay, because obviously we are moving towards even more consumption.
Yep.
For data management and storage.
Correct.
So, okay. Anyone else? Any other questions? Yeah, okay. I think that's about it, Eduardo. We thank you very much for your time and all this very useful information. I'm going to stop the recording right now.
Yep. So thank you, Yanis, to invite us and me to provide this presentation. As Maptek, we believe that we need to continue supporting the universities, particularly to make sure that this industry, first of all, that we can attract talent to continue in this industry, because as I mentioned multiple times with the presentation, mining is not going to go away. We just need to learn how to do things sustainable, to make sure that we are part of the whole ecosystem moving forward. So yeah, no, thank you again. Anytime, really.
Great.
Anytime.
And I should take this opportunity to thank Maptek, of course, for the support all these years with the software and the knowledge and the data they provided to our courses. Okay, so thank you very much.
Perfect. Thank you, guys. Have a good one.
Day. Bye.
Bye-bye.